Hi everyone, welcome to another video. In this video I will be explaining path traversal vulnerability. What is it, how it's exploited, and how it affects web applications. A path traversal vulnerability, or local file inclusion bug as it's more commonly known, allows an attacker to access internal files outside the web directory, which normally would be restricted. Topics I will be covering today are understanding local file inclusion vulnerability, how to identify local file inclusion / remote file inclusion vulnerability, how to exploit vulnerable parameters, how to prevent local file inclusion / remote file inclusion through sanitizing input and modifying configuration files, learn different payloads, tools, and escalating attack vectors. In this slide I will be discussing what is path traversal vulnerability. A path traversal attack, also known as a directory traversal, aims to access files and directories that are stored outside the web root folder by manipulating variables that reference files with .. sequences and variations, or by using absolute file paths. It may be possible to access arbitrary files and directories stored on the file system, including application source code or configuration and critical system files. It should be noted that access to files is limited by system operational access control. On the right, we've got a picture that outlines the steps to perform path traversal attack. Hacker identifies web application with insufficient filtering or validation of browser import from users. Valid GET request is used to retrieve and return an expected file from the web server. You can see there's a vulnerable parameter named file and a normal file called filename.php. An attacker is injecting a exploit to access the etc password file. Hacker modifies URL starting using .. directive in attempt to retrieve desired file from higher directory. GET request is performed and hacker is granted access to the file containing sensitive information without proper validation. Key points: if a developer uses the include function or the required function to process files and does not sanitize import, it's vulnerable to LFI or maybe even RFI. Access to sensitive files on the server that otherwise would be restricted. In this slide, I'll be discussing paths of a Linux system. What is an absolute path? An absolute path is defined as the specifying the location of a file or directory from the root directory. In other words, we can say absolute path is a complete path from the start of the actual file system from / directory. What is a relative path? A relative path starts from the current directory, backstep to parent directory using .. to navigate to desired directory or file. Down below we have a diagram of a classic Linux structure. Starts at /, so if we wanted to get to the etc password file, we would do /etc /password. In this slide I'll be discussing what exactly are filters. A developer may use a blacklist / whitelist to filter out special characters or file names, such as .. and /, preventing you from executing payloads. The website still may be vulnerable, but you will need using encoding. Bypass: it may be possible to bypass filters. You will need to test different payloads and encodings. Evasion: try URL encoding to bypass filters. Try double URL encoding. Try 16-bit Unicode encoding, and I'll put the equivalent next to the examples. The developer may be filtering file names. You can use a null character at the end of the extension, for example, %00.pdf to bypass file name filters. If the server's running PHP version 7, you won't be able to use this. Try placing sequences within another, for example, ..// // and ..// // In this slide I'll be discussing how to exploit a local file inclusion. Down below you can see remote file inclusion as a vulnerable parameter name page. The attacker is attempting to execute malicious PHP code through a text file. The second example is the same, they're just trying to bypass a filter. Local file inclusion, there's two types of exploits. Absolute exploit path, which is /etc/password, and a relative path exploit, which is .. / 4 times etc password, basically just backstepping out the parent directory. Down below, if an exploit is successful, you'll get an output which is similar to this, which basically just lists all the users of the server. And on the right, I've listed some sensitive files you might want to see if you can access. Obviously, we've got etc password, Apache 2 and Nginx access and error logs. We've got the shadow file and the SSL private key, although you probably won't be able to access this unless the system administrator is an idiot. In this slide I'll be discussing preventing path traversal attacks. Set proper permissions such as root jail, making it impossible to access files outside the web path. Properly sanitize user input by blocking malicious characters. Modify PHP configuration file to prevent URL executing PHP scripts remotely. Change file names or sensitive files, making them harder to guess. Filter file names, only allow certain file names within the web path to be executed. In this slide I'll be going over tools we'll be using. The main tool we'll be using is called Burp Suite, which is a web interception proxy. Burp Suite Intruder, which is a tool for automating payloads. .pwn, which is an automated script to find local file inclusion vulnerabilities. Kali Linux, which is our attacking VM. Ubuntu, which is our target VM. Hi everyone, welcome to my tutorial on local file inclusion. In this video I'll just be going over how to exploit and fix local file inclusion vulnerabilities. As you can see, I'm just running a Ubuntu virtual machine. This is our target environment for running a vulnerable web application. To get started, we'll need to download some packages first. So just open up a terminal, do apt-get install. We'll need Apache web server. We'll need PHP. We'll need Git and a text editor tool called Pluma. As you can see, I've already installed these files. If this is your first time, it might take a little bit longer for you. So I've created some vulnerable PHP web applications that I've hosted on the GitHub repository, so we'll just download those now. We'll do git clone . The link for this is github.com/webofchaos lfi.git. The link for this will be in the description if you want to download it. As you can see, the repository has been cloned, and we've got a new folder here called LFI. Just click on it, and we've got a zip folder called lfi.zip. So we'll want to send this to our web directory. To do that, we'll just do sudo cp, which stands for copy path, and lfi.zip. And the path we want to send it to is var www.html, and as you can see, that's been done. So now we just have to navigate to our web directory. And you can see our zip here. So we'll just have to unzip it. And we can do this using sudo unzip lfi.git. .zip. And as you can see, all our files have been extracted. And here's the files for the web server. So for this one, I've created two PHP files. One's lfi_vol, which has the vulnerable PHP code in it. And I've created lfi_fix, which has the fixed version of the vulnerable code. So to put this, to launch a web server, open up a terminal and go sudo service apache2 start, and that should start a web server for us. And to see if this works, just go open up a browser and just go 0.0.0.0/lfi_vol.php, and if it's working, should be greeted with a page similar to this. So that's good. And we'll need the IP address of this machine so we can do some testing. So just go if config to get the IP address, and as you can see, just ends at 132. If you're running this on a virtual machine, the address will be different for you, so just keep that in mind. Now we're going to go over to our other virtual machine. This is just Kali Linux. This is our attacking machine, so we'll just open up a web browser. Firefox comes pre-installed, and we're just going to see if we can access the web server. And as you can see, it worked. So before we get started, we'll need to install an add-on called Foxy Proxy. Should be the first one. Just click Add to Firefox, and this tool basically just allows us to swap proxy servers more easily. So you can see we've got a new icon at the top right. Just click it, go Options, Add, under Title. I'll be calling it Burp. Call it Burp Suite or whatever you want. We need to add our IP address, so just go 127.0.0.1, which is just the local host, and we need to add a port, and which is 80. Click Save, exit, and as you can see, we've got a green burp button, which we'll be using later. So now we want to go to Applications, type in Burp, open up Burp Suite. And this is the Burp Suite framework. if you haven't used it before, Burp Suite is just a web application interception proxy. Allows us to intercept web requests and modify it and send it to the server and see what it does. So the first tab we'll be looking at is just click on proxy. You should see a button called interception is on, which is what we want. And just have a look at this web page. We can see there's a vulnerable parameter named file, and it looks like it has some links, a link to some PDF documents. So we'll just click on it and see what it does. Looks like it loads up the web application hacker's handbook, so you can read through this if you want to. Now we're just going to pay close attention to the URL. You can see it has a parameter named file, and it's got a file name here. So that looks like a good testing point for us. So we'll just go to Foxy Proxy, turn on burp. Now all our traffic will be transmitted through burp so we can see it. So we're just going to refresh the page here. As you can see, Burp Suite has picked up that request. Now we're going to use a tool called repeater. Just right click, send to repeater. Click on repeater. And what this allows us to do is send multiple requests, changing the payload each time. And so this is the original request, so we're just going to submit it just to see what the original request does. And when we scroll down, we see all this unreadable text. It looks like the web server is passing our PDF document. In encoding, we can't actually read. So what we're going to do is backspace this file name, and we're just going to see if it's vulnerable to local file inclusion. So we're just going to use the basic exploit, which is /etc /password. We'll just send this, scroll down, and as you can see, we've got an output, and it's returned all the list of users on the server, starting at root. And if we scroll down, we've got a user called Chaos, which is what we're currently running on a vulnerable VM. So let's try and access some other files now. Let's try and access the hosts file. As you can see, it's returned some data, just some local domains with that route to the local IP address. Not too useful here. Let's try and access the Apache log. To do this, we can do var -log -apache 2/access.log. And as you can see, nothing gets returned here, which just means we don't have the permissions to access it. If we did, we could try a technique called log poisoning by putting some PHP code in the user agent, and we could try getting a reverse shell on the system, but we won't be able to do that here. I think that vulnerability was fixed a couple of years ago. So now that we've confirmed we've got a local file inclusion vulnerability, you may be asking what can we try and do next. So there's a chance you might be able to exploit a remote file inclusion vulnerability in the system, so we're just going to try and test for that next. Before we do, we'll just go over to the target VM. We'll just go to other locations, computer, Etsy, type in PHP, click on 7.4, click on Apache 2, and this is the PHP configuration file. So to edit this, just go sudo pluma, which is the text editor we're using, php.ini, and make sure you enter sudo, otherwise you won't be able to save any of the changes. So we're looking for an option called allow_URL, so just go Control F, and then you should have a search box, and then do allow_URL. It looks like we've got two options here. The second one we want is called allow_include, and this basically just affects the include PHP function, and so we're just going to turn this to on. I'll explain what both of these do later. Just press Ctrl S or save, and now we're going to restart the Apache web server just so these changes can take effect. So to do that, you can do sudo service Apache 2 and then restart. That should have restarted the web server for us. So now we want to go to the home directory, or it could be any directory really. We'll need to create a new file. I'll just call this one test.txt, and if you're wondering why this is .txt instead of .php, we have to create a text file for it to be executed on the target server. If it's .php, it just runs on our local server, which is not something we want to do. So just open up this file, and we'll need to put in some PHP code here. So we'll do less than $PHP. We need to use a function called system, which just allows us to execute system commands. Just put in parentheses, single quote, ls, which basically just lists the files on the server, semicolon, question mark, greater than, and Control S will save. So that file's there. Then we'll want to start up a web server. So to do this, we can do PHP allows you to do this. You can do PHP -S, and you'll need to get the IP address of this machine. You can do this with ifconfig. As you can see, mine ends in 128, yours will be a little bit different, so just keep that in mind. Copy the IP address, put down colon, and a number at the end for a port you want to open. I usually do 48000, which is the common web port. As you can see, that's been started. So we're going to go over to burp, remove this file path, and then we're going to go http:// just enter the IP address of your attacking machine, followed by the port, followed by the text file that you just created. Mine's called test.txt, and we're going to hit send. And when we scroll down, we can see it's listed all the files on the target server. So we know 100% now that this server is vulnerable to remote file inclusion. So at this point, you can go back into the test file and change the commands to enter some different commands to get access to more sensitive files on the server. But I'm just going to demonstrate how we can get a remote shell on the target system, which basically just allows us to execute commands on the target server. So to do this, there's a tool built into Kali called MSF Venom. So we're just going to open that up, and MSF Venom is basically just a tool which is a database which has exploits and shell code in it that you could look up. So to do this, you can do MSF Venom -L payloads, and this will just list all the payloads that are in the database. As you can see, we've got some Windows ones, Ruby, Python, Linux, just has a list there. So to exploit this, we'll want a PHP payload. So we'll just go to shell payloads, pipeline, grep, PHP. So this will just try and match anything that's PHP in the word. And as you can see, it's printed a list of PHP payloads. So the one we want to use is PHP metaterpreter reverse underscore TCP. Click to highlight it. We just want to copy that, so just go Control Shift C. And to produce the payload, we need to do MSF Venom -P for payload. Paste that payload in. And there's two variables we need to edit. One's called lhost, which basically just stands for local host. We just enter our IP address or domain of the attacking machine we want to connect to. So you can just copy and paste the IP address here. So that's pasted in. And the next one is called lport, which is just the local port you want to connect to. You just use 443. Now we can do -F because we need to specify the format, which is raw, and -O for output, and just enter the file name of what you want to call it. I will just be using shell.php. And I've put in the IP address wrong, so I'll just delete that one. Put a 1 there. So as you can see, that's been done, and we've got a shell.php. So if we click that, this is our shell that will give us remote access. As you can see, it's got a variable for IP import. You can just go and change this whenever you want. So now we'll need to set up a program where we can listen for incoming connections. So to do this, Kali has a tool built in called Metasploit Framework. So we're just going to load that up. And there's a tool built in called multi-handler, so we're just going to use that to listen for incoming connections. So we can do use exploit /multi/handler, and now we just need to copy the payload that we had before, so just go set payload. Just copy this payload here. Copy and paste it in. Now we'll want to set an lhost as you just do 0.0.0.0, and we'll need to set an L port as well, which as per the payload it's 443. Now we just need to hit run. As you can see, this is listening for local connections going to any IP address on this machine. So now we'll go over to Burp Suite. We will change test.txt to shell.txt, and I forgot to change the extension, so we'll do that now. We'll just change this to .txt so it can run. Go back and hit send. And as you can see, we've got our Metinterpreter shell running at the moment. So if you haven't used this program before, you can do help to show a list of commands, and these are all the commands you can run on the machine. But at the moment we're just interested in using the shell function. To do that you can do shell, and this will just drop into a shell and let us execute system commands. As you can see, it's just listed here. And we're going to use a command called who am I, which lists our current permissions that we have on the server. And if you didn't know, servers usually run on www-data. Pretty much all the servers do, which means we don't really have any significant permissions on the server, so we'll need to escalate our permissions for us to gain access to more sensitive documents. So now we're just going to navigate to the home directory of the current user, which is chaos, and you can see we're able to list some folders. We'll just go to downloads, list. We've got a file called pass.txt, so we're just going to try and read that with cat pass.txt. And as you can see, it's got a few passwords here. Now there's a tool on Ubuntu called sucrack. It basically allows us to brute force the passwords of users on the system. So I've installed that, so I'll just demonstrate that tool. Obviously if you're using this on any other server, they're probably not going to have it installed, so you'll need to download the standalone binary for that to work. So to use the tool we can do sucrack-h, which will give us a example of the tool running here. So we can do sucrack-a-w 10-s 10-u. You can just enter the user you want to crack. This one has root, but we want to crack the chaos user, and click enter. Just going to have to run that command again. Just enter the user here, and then I forgot to put in the password file, which is called pass.txt. Click enter. As you can see, it's cracked the password for chaos, and the password is chaos. So now to escalate our privileges, we just need to do su-l chaos, and it will prompt us for a password. Just enter the password, which is also chaos. Enter the command who am I, and as you can see we've successfully escalated our privileges. So with this we have more access, so let's try and access the SSH private key. To do this we can do cat home the user .ssh id underscore RSA. Would help if I spelled it properly. And as you can see we've got the SSH private key. So if this was a production server and they were running SSH, so we could, as an attacker, what we could do, we could basically get permanent access to the target web server using the SSH key. To sort of maintain access, but I just wanted to show you what we could do now that we got access to this machine through an RFI vulnerability. So let's just go back to our burp suite. So now that I've demonstrated an LFI and a RFI vulnerability, let's see what we can do to fix that, to stop an attacker from exploiting it. So let's just go back to the target machine, go back to this PHP configuration file, and where it says allow underscore URL underscore f open and allow underscore URL underscore include, we're going to basically turn both of these off. So if you don't know what these do, these basically allow the execution of files remotely. So essentially if we turn them off, then that makes it impossible for an attacker to execute files remotely. The only files that can be executed are the local ones that the developer has on the server. So we'll just go capital O and then FF, and we'll do the same for the above. Press Ctrl S or save. And we'll just restart the server. As you can see, that's been done. So we'll just go over to the Kali Linux machine again. And I'm just going to quit out of this just because we don't need it. So I'll just try and execute the test.txt file again, just to show you that it doesn't work anymore. As you can see, we've got nothing returned, it's just HTML. So let's try the other one as well, shell.txt. Nothing on that one. So as you can see, we can no longer execute remote files. So that vulnerability has been fixed now. Now let's take a look at fixing local file inclusion bugs. Just go to the target virtual machine again, and let's just navigate to the web path. And let's just load up the vulnerable LFI file. LFI underscore vul.php. So let's scroll down. As you can see, this has the source code for the vulnerable file which is on the web server. and I've put a comment here basically telling you which functions are vulnerable. So we've got a vulnerable get parameter, which doesn't validate any import whatsoever, which obviously is really bad. And so the one we want to look at here is vulnerable to LFI and RFI, does not validate input. So if you're wondering how we can fix this, what we can do, we can put a if statement in. So to do that, we can do if. There's a built-in function called strpos, which just stands for string position, and we'll want to put the user import variable in first, which is just above here, called file. So we can do $file, comma, single quote, and we'll need to put in the characters that we want to exclude. So I'll just put in // to try and filter out some local file inclusion. And I'm just going to close that and put a pipeline in, and I'll put another filter in to filter out file names. $file, single quote, .txt, and I'll just close that. Then you're going to want to do a curly bracket, and we need to run some code. So essentially, if any of these characters are found, we're going to echo something to the screen saying exploit detected, semicolon, and closing curly bracket. So essentially what this does, it reads the input from the user. It'll try and match some patterns, for example // and if they're using a file name called .txt, and if any of these match, it'll say exploit detected, and so we can see that the filters we're putting in have taken effect. Now we want to put an else statement in as well, curly bracket, and curly bracket at the end there. So essentially, if none of these characters are matched, it'll just run the following, and the include function will just run whatever file that you give it. So let's go Control S, go back to the PHP. I'll just need to turn this back on just so I can demonstrate the file name filters again. Need to do a restart, go to the attacking machine, so if I try and execute a .txt file, it should give us exploit detected, so we can see that vulnerable parameter. It's validated the import we've gathered from the server, and it's rejected the exploit, which is a good thing. So now we'll want to check local file inclusion and see if we can still do it. So I'm just going to do a relative path exploit. So we'll do // etc password, and it looks like it has detected that exploit as well, which is good. So essentially we can, to try and bypass this, we can try and do encoding and that kind of stuff, like URL encoding and whatnot. So I'll just try and explain the text file a little bit more. So essentially, if we were going to try and change the extension of this file to .txt, and we just add that on the end. Try and run it, and as you can see, it's still detected. So even if we try to add encoding to this, that wouldn't work either. So it's obviously catching that file. So if we wanted to bypass this, we essentially just take off all the extensions. As you can see, it's just got a test there. Just go back and put in test, and as you can see, it's run the files here. So we've successfully bypassed that filter. So you can tell that is a bad filter. So obviously don't filter for that, because it won't work. And for our previous one as well, we can bypass the filter that I put on there by going /etc/password, and as you can see, we've still got the list of users that are coming up. And the reason why this works is because it's blocking a relative path, so it's looking for the // or // So an attacker can just put in a slash to bypass and still access the files that they need on the server. So we now know that is a bad filter as well. And before I show you some proper filtering and that kind of stuff that we can do with it, I'll just demonstrate some automated tools. So what we can do, we can just go send to intruder, go to payloads, so we can here's our request here, and we're going to get parameter. So this looks like it's added, so we'll just go to payloads, and we will need to download some payload files. So I'll just turn this off for a sec. Just go sec lists, GitHub, should be the first one here. So we're just going to clone this into our downloads. And this might take a while. This is just it's basically just a repository of payloads and fuzzing tools you can use for web applications. This will probably take a while just because the file size is pretty big. have a decent internet connection. This will probably be done in a couple of seconds, but obviously my internet isn't that good. And that repository has been cloned. So we'll just go back to Burp Suite. We need to load a word list in here. So just go download, sec lists, fuzzing, LFI. And we'll just use the jhaddix.txt word list, and as you can see there's a bunch of different payloads in here. We're just going to brute force. And once that's added, we can do start attack. And I'll probably have to do some filtering with this one by the looks of it. So just exit out of that. Go to options, scroll down to grep extract, click add. Just click out of that. I'll just put in a payload to trigger the message that we got. And we basically just need to access string here. Just click on detected, click OK, because we just need to match the string, and if this wasn't detected, and we know the exploit succeeded. So just go start attack. So you can see here we've got detected for a bunch of these. These are the exploits that didn't work, and the ones with the blank spaces, those are the exploits or payloads that do work. So this is just useful for testing filters on vulnerable web applications. So essentially developers might use multiple filters, so automation is a good way of testing for this. So to give you an example, so if we can check here, click on the response, see the response from the server, and as you can see we've got exploit detected. And if we look at one that has all this URL encoding on it, just scroll down, and as you can see nothing has been detected here. Obviously the payload didn't actually work on this one, but it will let you know what filters are running on the server. So you can automate attacks with Intruder on this one, and there's another tool built into Kali called .pwn, so we'll just take a look at that one. So we can do sudo apt-get install .pwn, and we'll just install that tool now. And as you can see, this is our .pwn tool here. So the syntax and how to use this tool, essentially will be, we need a -m for mode, and we'll be using the http-URL, and we'll need a URL for the vulnerable, to check see if a website is vulnerable. So we can just copy this path here, and we'll just need to enter the IP address as well. So we'll just copy that from the browser, copy it in, so that's our URL. And if we look down here as well, we'll need to put in a -k to essentially match the output. So as you can see, we'll just put in root colon, just to match the root in the HTML, and if it matches that, then we know it succeeds. We'll just have a look at some other options that we need. So we'll need to put in caps traversal, and this will essentially just replace all the payloads for this parameter here. so we can check see if it's vulnerable, and we'll just hit enter. So it's basically just going to run through all these payloads, and if something succeeds, it'll say vulnerable on the side here. So we'll just let that run for a minute. While that's running, I'll just make some changes to the PHP configuration files here. Just turn this back off. So it's more secure now. Not too sure how far the list down the back Etsy password is, so I'll just have to keep this running for a little bit longer. In the meantime, let's take a look at the PHP file. So obviously we've had a look at // and text. So obviously those filters are no good, and probably shouldn't use them. So you might be asking, how do we successfully mitigate these exploits? And I'll just show you the fix file which I've created, which essentially fixes all the vulnerabilities that we've been having. So essentially the fix for this one is we essentially need to store the current working directory in a variable. So essentially it'll look something like this. We'll just go to the web directory. So I just enter the command pwd. You can see var www/html. So that's our current working directory of the web server. And PHP has a built-in function called get cwd, which stands for current working directory, which essentially just prints that string I just showed you and stores it in a variable called path. And we've got another one called real path, which essentially just reads the file path of whatever the person is trying to access. And if we go down here, we've got string position. It's essentially comparing the real path to the path of the web directory. And if it doesn't match, essentially it'll say exploit failed, and it won't run this file here. So that essentially fixes it, and I'll show you in a minute. I'm not too sure where the slashes are on this one, but it should say vulnerable over here. So I'll just exit out of that, just because it's taking too long. So now I've just got to go to the target machine again. So now I'll just exit out of LFI vuln.php. I'll just need to edit the LFI underscore fix.php, just because I made a mistake with this one. So this is again still using the include function. So let's try and access this and try and access the different web page. So as you can see, we've got the same website here. We'll just click on a file. We'll just have to fix some links up here, just a sec. Before this video goes live, I'll fix these links in the GitHub repository, so you won't have to worry about it. I just forgot to do it. And as you can see, it's loaded the files like it was supposed to. So I'll just turn inception off for this one, turn it back on, turn inception on, refresh the page, and again we're just going to try and follow the same process as we did before, and we'll just try and load some payloads to see if we can get past the filter. I don't think it'll be possible, of course. You see exploit failed for the absolute path for local file inclusion. Now let's try a relative path. As you can see, that failed as well. Now let's try remote file inclusion. Exploit failed, so that's no good as well. And what we can do, we can try some URL encoding, double encoding as well. So we could do backslash encode as URL, copy that, backspace, @C, paste it again, password, exploit failed again, so let's do encode as, let's do double URL encoding. As you can see, that's failed again, so that doesn't work. So yeah, that pretty much solves local file inclusion and remote file inclusion vulnerability. So let's just go back to the target machine again. So basically, the way this works, anything that's not in this web directory automatically gets rejected. So if someone's trying to access files outside of that directory, then the server will basically reject it, just because it's not, you can only execute files within the web path. So that essentially fixes the vulnerability. And just to note, you'll notice there's a still comment up here. Vulnerable get parameter, vulnerable to blind XSS. This parameter here is still vulnerable to blind XSS, which I'll probably be demonstrating in another video. I'll do a video on reflective XSS and stored XSS using the same files. But that pretty much wraps up this video. So if you like this video, leave a comment and let me know if there's anything you want to see in the next one. Catch you guys later.